In chapter exercise 2, let's go. The first question. The first question is domain of the function f(x) is equal to square root of cosine x minus 1 upon 2 upon square root of 6 plus 35 x minus 6x squared. So, right, I mean, this should be positive. So, cosine of x must be equal to 1 upon 2. When does that happen? So, x must be in what space, right? That happens at this point and at that point, and yeah, I guess that's the thing. So, negative pi upon 3 to pi upon 3, but basically 2 and pi plus this guy, right? So that's already there. And what else do you want? This thing. So 6 plus 35x minus 6x squared, that should be positive or bigger than or equal to 0 actually. Yeah. So this means 6x squared minus 35x minus 6, right? That must be less than or equal to 0. So this is like 6x squared minus 36x plus x minus 6 is less than or equal to 0. So like x minus 6, then you got 6x minus, plus 1, right? Of course, less than or equal to 0. Is that correct? I guess it should be. Yeah, yeah, that's right. So like x just, belongs to negative 1/6 to 6th, right? That should, hey, it's not actually equal to 0. It should be strictly less than 0. So round brackets. Okay, once we have this, in this unit circle, what angle does this represent? So 2 pi is, basically, yeah, okay, so 2 pi is, remind me, 6 point something, right? So 6.28, whatever. Sure. Right. Let me guess. So you got negative 1 upon 6 first of all. It's coming somewhere here. Because pi upon 3, that's negative 1 point something. So it's clearly above that. So you already got negative 1 upon 6 all the way to pi upon 3. Okay, so that's the thing. Oh, this is not included, and that is included. Okay, union. So now you go like this and you reach over here. It's like 2 pi upon 2 pi minus pi upon 3 is going to be 5 pi upon 3, right? Of course, so 5 pi upon 3 plus something, right? So 5 pi upon 3, is this bigger than 6 or not? Yeah, okay, 5 times, it's like asking, is this bigger than 6? That's like asking 5 pi bigger than 18. But pi is just 3.14 something. Okay, maybe you should go for pi bigger than 18 upon 2. Sorry, upon 5. What am I doing? It's like equal to 3.6, isn't it? Because of course. So pi is 3.14, and it's actually less than that. What does that mean? 5 pi upon 3 is less than 6. So yeah, 5 pi upon 3 to 6. That should also be there. There we go. That's the answer. Right. And where am I going to get that? I guess D, because negative 1 upon 6 to pi upon 3. Wait, what? 2 pi? No, it doesn't make any sense. Pi upon 3. 5 pi upon 3 to 6. So C is the answer. Next question. So first C. Now these are some good questions. Next. Second. Second is the range of the function f of x is equal to, f of x is equal to cosine inverse of, okay, f of x. Okay. So the range of this function, I mean, okay, like this guy just goes from, it's cosine inverse, you are saying, huh? So it can take only some values. It can take like 0, 1, and then negative 1. And other than that, no other value will actually work. So negative 1 gives us pi. This thing gives us pi upon 2. This thing gives us 0, right? So those are the things. So curly bracket 0, pi upon 2 pi. A is the answer. Next. Third is the range of the function f of x is equal to 4 tan x cosine x, right? Isn't that like 4 sine x basically? So negative 4 to 4, yeah. Wait a second. In the domain of this function, you don't have the values wherever cosine x becomes 0, because those make tan x to be not defined. So, right, those values are not allowed, which means cosine x actually cannot be 0. Whenever that happens, that's when you have sin x reaching its extreme values. So, yeah, not inclusive, negative 4 to 4. Fourth, come on. Range of the function f of x is equal to cosine power 4x upon 5 and a sine power 4x upon 5. Okay. Wait. So cosine power 4 minus sine power 4. That's like c square minus s square times c square plus s square is just c square minus s square, which is basically 2. Basically cosine of 2 times of the thing. So 2x upon 5, right? So range of this function is clearly just negative 1 to 1 inclusive. And that is option A. Next question. Fifth. And yeah, this is defined everywhere, so cool. Range of this function, sine of square root of x. Okay, so just, let x with some positive numbers, right? So square root of x actually goes from 0 to infinity, so all the arguments are allowed, right? Yeah, okay, that means, of course, it's negative 1 to 1 inclusive. A is the answer. Next, sixth. Range of the function cosine of 2 sine of x. So 2 sine of x goes from negative 2 to 2, right? And wait, what? Negative 2 to 2? Think about it. So you are on this unit circle. Where is negative 2 exactly? So, okay, negative 2 to 2. Huh? I mean, okay, it's even function anyway. So just go from 0 to 2. That will cover all the possibilities. Yeah, that, where did I go? Yeah, okay, this thing. So 0 to 2. And pi is 3 point something, so it only goes till here. So yeah, like, okay, cosine of 2 to cosine of 0, like 1. Okay, this is the range first. And where's the thing? A, I guess. Next, seventh. Seventh is range of the function f is equal to sine of log base 2 of, look, log base 2 of x can go to all real numbers. No big deal of that. Sine of that is negative 1 to 1 inclusive. So A. Eighth. Range of the function 3 minus 2 power x. So 2 power x, right? I mean, it goes for all positive values. So okay, 0 is not inclusive, but yeah. So 0 not inclusive, that just means the maximum value is 3 not inclusive, and the minimum value, uh, whenever this goes to infinity or something, that's negative infinity, right? Yeah, that's the thing. So negative infinity to 3. Cool, that should do it. Not inclusive. So 8b. Because 0 only happens when x approaches negative infinity, which doesn't make any sense. How can that be? Yeah, okay, next question. You cannot have infinity in the domain. Ninth. Range of the function fx is equal to 3x plus this guy, okay, upon that, whatever. It's like 3 plus, oh, and by the way, x is equal to 0 is not allowed, huh? Yeah. This thing is basically just the signum function of x, except x equal to 0 is not allowed. What does that even mean? It can only be 3 plus 1 or 3 minus 1. It cannot be 3 plus 0. So 4 and 2. So 2 and 4 in curly bracket. Yeah. Next question. 10th. 10th is range of the function of x is equal to cot square of x minus pi upon 4. Huh? Once again, x minus pi upon 4 is just some argument. We don't care about that. Cot square of x is what we look for, right? Cot square of theta doesn't it? Yeah, doesn't really matter all that much because x minus pi upon 4 goes from negative infinity to infinity. So cool, right? Cot square of theta. So the range of that function. Ooh, I mean, cot has the range of all real numbers. So square of that is gonna have the range of, all positive real or okay non-negative real numbers. So 0 inclusive, infinity not inclusive. I guess C should do it, right? Okay. Yeah, and cot can definitely be 0 whenever you like have pi upon 4 or something. So x equal to pi upon 4 plus pi upon 2 or something. That happens, right? Okay, 11th, ratio of the function is equal to sine inverse of x square plus 1 upon 2 tan inverse of x. Oh, this is a different. It's kind of complicated, isn't it? Okay. X square, you are saying. So think about its domain first of all. Okay, so like x, you know what? Instead of, yeah, okay, x square, instead of that, I'll just put u. So sine inverse of u plus 1 upon 2 tan inverse of u under the restriction that, sorry, it's minus 1, that u must be greater than or equal to 0, right? Okay, in that case, so of course, u is just going from 0 to 1, right? Okay, yeah. So u is going from 0 to 1. Yeah, okay. That's probably not the best notation for this thing. So maybe this is the thing. I don't know. You get the idea. We'll start off at 0. And look, it's tan of something. You know what? Yeah, instead of that, wait, isn't that tan inverse? Okay, cool. Uh, right. So tan inverse, right? Just think about a graph of tan. Tan is some kind of function like that, right? So in negative pi upon 2 to pi upon 2, right, whenever x belongs to that range. Wait, tan in, you know what? Sure, tan inverse is just, take this graph, but invert. It's like, okay, just flip it, basically. So this is flipped like that. Okay, you got pi upon 2 at infinity and then negative pi upon 2 at, you get the idea, right? That's how tan inverse is probably going to look. What does that mean? That it's actually a 1 1 function that's continuously increasing and whatever. So what does that mean? As u increases, this thing actually increases, and similarly sine inverse of u also increases because, right, yeah, and it's only going from 0 to 1, so of course it's going to increase from 0 to pi upon 2. Sure. What does that mean? This whole thing is just an increasing function. Hey, that's kind of nice, isn't it? So just to figure out the maximum value, just put the maximum value of u, which is 1. So pi upon 2 is the maximum value inclusive, and then the minimum value is whenever u equal to 0. So, half tan inverse of negative 1, that's like negative pi upon 8, because, okay. So that's the range, isn't it? So B is the answer. Next question. Oh, come on. Next, 12th. 12th is, which of the following functions are identical? Natural log of x square, and then, I mean, okay, that's like, yeah, the thing is like this is defined for all real values actually. That's perfect. Right, this is not defined for all real values because it's only defined for positive real values. So no, these are not the same. Cosec x and 1 upon sine of x. Yeah, I guess this is in fact, like these two are in fact the same, because, right, for this to actually happen, x must lie in the domain of sine. That's like real numbers, right? So x can be any real number, and it's gonna work out. Sure. Except at 0, because at 0, or any multiple of pi for that matter, right? At those points, it's like gonna approach some kind of asymptote, so that doesn't work. That makes sense. Yes, it should. So yeah, these are actually the same stuff. Okay, so B is correct. What about this guy? Tan x and 1 upon cot x. I guess maybe. Wait a second. No. So think about it. At x equal to pi upon 2, this thing, okay, maybe not. No, wait. Not pi upon 2. It should be something else. Okay, at x equal to pi. So at x equal to pi, this thing is well defined, right? It's 0. But this thing, it's not defined. Although, take the limiting case, it would be the same thing as that. But yeah, I mean, it's not defined because cot x is not defined. So 1 upon that's all not defined. Although it would be defined if we try to do it. Okay, so C, not the same functions. And yeah, like, okay, B, these are the same functions. Cool. Natural log of e power x and, okay, e power natural log of x. And that is x, and this is also x. Cool. But okay, this thing is for all real values, but this is not for all real values. Right. So that should be doing it. What does it mean? That B is the answer. Next question. 13th. 13 is which of the following pair of functions are identical? Once again, same kind of question. Cot square x and then cosine square x. What? And cot square x minus cosine square x. This is like, what is this? Okay, so cot must be defined, cosine must be defined, and then it's gonna be defined. Cool. So at least the domain part is checked out. What else? These are the same, right? So c power 4 upon s square, that's equal to, I mean, I'm questioning, is it actually equal to c square upon s square minus c square, right? That is the thing, which is like equal to c square times 1 minus s square upon s square, which yeah turns out to be c power 4 upon s square. So yes, domain part is defined, and the equality part is, sorry, domain part works out, the equality part also works out, so A works out. Cool. Right, so these are identical. No need for checking out other options, but still I'm gonna do it because I wanna see if they made some kind of mistake once again. Yeah, okay. Tan x times cot x, that's 1. This is also 1, except that this is not defined at some, right, some points. Uh, Let me look at the same point. Is also, oh, so whenever cosine x is 0, this thing is not defined. But over here, you got no mention of cosine x at all. So yeah, some holes in this and those holes are not in g of x. Okay, so that's why not the same function. Square root of 1. Okay, square root of 1 minus cosine of 2x. Right, it's like 2 sine square of x upon 2, right? Sine square of x, but the square root of that is like mod of sine x. You understand that? It's mod of sine x, not sine x. So obviously not the same. Once again, the same situation, mod of x and okay, this is kind of weird. Like this is defined for all real values. This is not defined for all real values. So yeah, right. Okay, next question. 14th. Let a be equal to this. Set the number of 1 functions from a to a such that f of I is not equal to I. So a is this thing 1, 2, 3, 4. You want to go from a to a, and it's 1, 1. So from an element you can only okay, understandable, right? And f of I is not equal to I. Hey, isn't that like the, yeah, that's like the number of derangements they could have. Isn't it correct? So for 1, you will have, yeah, basically one pair of you want to find pairs, of course. Exactly. So yeah, that's just the derangements. Isn't that right? It's like d of 4. So 4 numbers, that's why d4. Isn't that right? So we know the formula for that, like, okay, dn is just equal to n minus 1 times dn minus 1 and then plus dn minus 2, isn't it? What was the thing once again? How did we actually get that? So the first guy can give its hat. You should see that video where I explained the arrangement. So first guy gives its hat to, okay, if you just switch the hats, right, between two people, right, then you got the n minus 2 for n minus 2 people left. You also have to derange them, but these two are already arranged. That's why n minus 2, so this part. But then there are n minus 1 such things, right? Okay, n minus 1 such switches you can do for a single person, right? Included. That's why n minus 1. And then yeah, okay. And then the n minus 1 is because, okay, if you just give this guy its hat, but you don't give it this guy's hat, and then there are like n minus 1 hats and n minus 1 people, so this happens. Makes sense, right? So it's gonna work out. Let's do it. D4. You know what is the start of at the very p6? So what's d of 2? There's only one way. What's d of 3? So got like 1, 2, 3, and then 1, 2, 3. You don't want this. You can have I don't know. So you got 2 over here maybe, and then 3 and 1 over here. It's like 3 and 1, and then you got 1 and 3. So that's already 2, and then plus you could have 3 over here, and then am I doing this correctly? Yes, I am. You could have 3 over here, and then this would be having just 2 and 1. So you cannot have 2 over here. So it should just be 2 over here. There's only one such way. That's going to be 3. There we go. D3 is just 3. So the whole thing is like 3 times of 3 plus 1, I guess, because that's what D4 is going to be. Exactly. Which means it's 12. So 12 ways, huh? Yeah. So 14th. Right? 1, 1 functions. Of course, if it's 1, 1, it's got to be like that. Why is that not here? If I is not equal to I mean, I did that. What's the problem over here? It should have been this, right? D4, of course. D2, there's only one way. D3, there's 3 ways. And then it's like 3 times of it. Of course, it's going to be 12. Why is that not here? You got 24, 9, 256. No idea how that turns out, everything. Okay. Where am I missing anything? What's this? Just the derangements? What could possibly go wrong? I don't get it. Right? It's the number of derangements. That's the thing. Okay, what can I say? Like 12 is the answer, and it's not in options. I don't get what I did wrong. You clearly said f of I is not equal to I, and it's 1, 1. So this has to be matched with exactly one pair, and then that pair must be matched with this exactly. Yeah, that's what I did. What's the big deal about it? Right? Whatever, next question. Clearly, there's like 4 of these guys, and that's just 4 of these guys, so it must be filled completely. That just means it's. Okay, just move on. 15th. Probably 14th is incorrect. They don't have 12 in the options. It should be there. Number of onto functions A, B, C, D to P, Q, R. Okay. So A can be any one of these guys, and then B can be any one of these guys. Whatever. You just want onto functions, right? So P, Q, R must be completely used up. Cool. Right. Oh, that's gonna be some complicated, problematic thing. Yeah. Okay. You got these two over here and there. Is that none of them is left open, basically? Oh god, that's very weird. We are like distributing 4 distinguishable objects to 3 distinguishable containers. That's weird. Okay, just inclusion exclusion is probably the way to go. So you got 3 power 4 base without the restriction that should be an onto function minus. So what's the first restriction you break is that A actually goes. Okay, A doesn't actually. Sorry. First restriction you break is that P doesn't get any pre-image, right? Okay, and then there are like 3 ways that you can actually do that, like P, then Q, then R. So 3 times off. So what happens if P doesn't get a pre-image? You got Q and R only, right? Okay, so just got 2 power 4. And then plus the next restriction you break is 2 of these images don't have pre-images. So all of them are just mapped to R. There's 1 power 4, only one way of doing that, of course. And there are 3 ways you can choose these 2 guys. So 3C2. That's why, like, okay, yeah, just 1 power 4 times 3. So plus 3 times of 1 power 4. Any more thing? Okay, that's the last restriction you can break. Is like none of these have anything. That doesn't make any sense. Doesn't make any sense, of course. So this is the thing. This is the number of ways, I guess. So you can take a 3 common. You got 3 power 3 is just 27 minus 16 and then plus 1. So 3 times of what's this gonna be? 11 plus like 12. 36, I guess. B is the answer. Next, 16th. 16th is f real to real fx is equal to 2 power mod x minus 2 power negative x is. So whenever x is negative, this is just 0. Whenever x is positive, it's like basically 2 power x minus 2 power negative x, which, okay, think about it. What about this guy's derivative? You can do that, right? It's like natural log 2 is common. You got 2 power x plus 2 power negative x, which is positive. So it's just increasing throughout. And x equal to 0, it's just going to be 0, right? So it's continuous. It's, and x equal to 0, its derivative is not 0. So it's not differentiable. Hey, what am I doing? Why am I doing that? Okay, it's just like this. 0 throughout this and, like that. Sure. So this is a many to one function, of course, because for all negative x values, you get the same value. And it's going to real numbers. Well, it's okay. It's always positive. So, it's not onto, it's into, and it's many one. So A is the answer. Next question. 17th. 17th is negative 1 to 1 to negative 1 to 1. If x is sine of 2x, then oh wait, but it's negative 1. So okay, 2x goes from negative 2 to 2, and 5 upon 2 is like, okay, negative 5 upon 2 is 1 point something. What does that mean? Yeah, like negative 1 to 1, all the stuff is covered. So it is definitely on 2, but it's many 2. It's many 1 as well, because, right, negative 1 to 1, sorry, negative 2 to 2 is arranged like this because it's slightly more than 5 upon 2, right? So the sine values, which is the y coordinate on this unit circle, yeah, so like for 2 different angles, you can have the same y value, and that's problematic, isn't it? Yeah. Which basically means that it's many 1, and also it's on 2 because all the stuff is covered, right? And then there's like repetition as well, so it's many 1 and on 2. So B. Next, 18th. Remember, a function can also be thought of as a graph, but at the same time, it can also be thought of as, a correlation. Sorry, what am I doing? Sorry, something like, yeah, pre-images and images. So that's what I did basically. So for the angles, which are the pre-images, you just figure out the image, which is the y coordinate. Does that make any sense? I guess it should, given that I already explained how a function behaves in the theory part. Okay, 18th. X cube, oh, I don't want answers. X cube minus 2x squared plus 5x plus 3. So what about this guy? Just take the derivative of this guy. We'll see. Oh, wait, it's already just, on 2. We can say that for sure. Just have to check if it's many one or not. 3x squared minus 4x plus 5, this guy's derivative. What's the discriminant of this derivative? It's got 16 minus 4 times of AC is just, 15. So, right, that's like 4 times of 4 minus 15, which is a negative 11. So it's negative, that's what matters. The thing is, this is always positive in that case, right? Because discriminant is less than 0 strictly. What that means is, like this function is always increasing, which means it's a bijection basically. So it's it's 1 1 and it's on 2. So it's C. Next question. 19th. Let f from xyz, the set to abc set, be 1 1 function. It is known that only one of these statements is true and the remaining 2 are false. Ooh. So the first statement is f of x is not equal to b, then f of y is equal to b. What is y? Oh, okay, this guy, right? So one of these statements is true and the remaining 2 are false. Let's think about it. How many 1 1 functions can we actually get? See, factorial, you got 6 such functions. So do you have to check all such functions? I don't know. The remaining 2 are false. One of these statements is true. Okay. Huh. That's interesting. So 2 of these must be false, right? Think about it. What if the second one is true? Then these 2 are false. F of x is equal to b, f of z is equal to a, f of y equal to b, right? So 1 and 2 are contradictory, which makes no sense, right? So second one cannot be true. What about the first one is true? So f of x is not equal to b. Then this must be false. F of y cannot be equal to b. Okay, and f of z is equal to a. You know that one. So z is mapped to a. This guy is true. So that just means y must be mapped to c, but then x must be mapped to c. Wait. If this statement is true, then f of x is not equal to b, and f of y is also not equal to b, but f of z is also, not equal to c because it's actually equal to a. Sorry, not equal to b because it's equal to a. What does that mean? That there's no pre-image of b. That doesn't make any sense. So first cannot be correct. Then what about the last one? Third might be correct and these two might be false. So f of z is equal to a. So z goes to a. Then you got the second is like f of y is not equal to b. So y can only go to c, right? And then you have f of x is equal to b. So x goes to b, which makes perfect sense. That's how it should be. Then f inverse of a, that's of course z, right? So C is the answer. Next question, 20, right? F of x is equal to 3 sin x plus 5 cosine x plus a. F from real to this thing is an onto function. Okay, you gave us the rule and it's all real numbers. Of course, all real numbers. And it's 0 to 10 you are saying. Oh, so you gave us the range as well. It's an onto function, right? Because 4 to 1 is equal to the range, so that's why this is the range. So the following is correct. Sure, just need to figure out this guy's range. So the maximum value is like a plus square root of 9 plus 25 is 34, right? Yeah, of course, 34. And then the other one, so the minimum value is just a minus square root of 34, both inclusive by the way. So what you're saying is a minus square root of 34 is that correct? Why is the square root of 34? 9 plus 25, it's got to be just... If this was, 3 sin x plus 4 cosine x, that would have made perfect sense, but it's 5 cosine x. And now it doesn't make any sense. right? Because the max minus min value is just 10, and that's not possible because this, right, goes from negative square root of 34 to square root of 34, which, like, 2 square root of 34 is clearly not 10, which means this can never happen. This is not going to happen at all. Probably this should have been 4 cosine x, but then they messed up and wrote it as 5 cosine x. And okay, suppose it is 4, so I'm gonna write blue or something. Or you could just say none of these, but I guess it just messed up and it's not a trick question. So it's like 3 sine plus 4 cosine plus a. That's the only way you can have a, a range of 10, interval of 10, distance, whatever you call it. Okay, and then this is going to be a plus 5 and a minus 5. So then it's clear a minus 5 is equal to 0, a is equal to 5, and then of course it's going to be 10. Cool. And for some reason it's not included. Doesn't make any sense. It should be inclusive because, yeah, it does happen to be equal to that at some points, right? Oh god, it's correct. Look, the thing is, you made too many mistakes while writing this question. I'm gonna say it's none of these, right? Okay, just another correction. So it's going from real to square brackets, right? Okay, and then I can write down the answer. It's like a equal to 5. So 8. Okay, that should be doing it. So now answer key. First guy C, second guy A. P A A. Okay, A A. B C C. 11th B B A. 14th it's D. Okay, it's wrong. We just know that it's not correct. Okay, 15th B. 16th A. 17th B. You got 18th D. Okay, 20 as well. It's, wait, 19th is B and 20 is D. What? This is weird. How did that happen? Let's see what went wrong. So you're saying 18C. Why? Sorry, 18C is wrong and D is correct. Oh, sorry, it's 1 1 and on 2. Why did I say 1 1 and into? That's okay. So yeah, that's right. Just made a silly mistake. Didn't read it correctly. Okay, 19th. So C is wrong, B is correct. So okay, f inverse of, so like basically f of y is equal to a, right? Huh. What was the thing once again, that the third one was correct? So f of z. Can't believe I made such mistakes now. Right, I must have matched this to C while speaking. It's definitely not like that. So what is the thing once again? Z does not go to A. Okay, X goes to B at least. Okay, X goes to B. Y cannot go to B, so it has to go to C, right? So the third one is wrong, and then Y must go to C, and then you got Z is correct. So something went wrong, isn't it? The third one cannot be correct. Okay, but we tried out everything sequentially, so what's going wrong? Let's just try it out once again. So first, if the first one is correct and other two are false, right? X is not equal to B. Okay, then other two are false. It just means f of z is equal to A. So this is going to A. And X is not going to, sorry, Y is not going to B, which means it must go to C. And X is equal to B. Wait, this was the thing, of course. So why did I not take that? I don't know what happened exactly. But yeah, okay, f inverse of A is, right, it's Z. You can see that. Wait, what? Let me just see in that case. That's B. You are saying it's what? Something's weird, isn't it? Did I do that correctly? Okay, the first one is correct and the other two are false. So is f of x not equal to b? Oh, oh, sorry. Oops. That makes sense. Right, this was wrong, of course. Uh, Man, why am I making mistakes like these? Okay, so clearly if the first one is false, then sorry, first one is true, then second one is false, which means f of y is not equal to b as well, which means and then f of z is equal to a. So clearly b doesn't have a pre-image, so first one cannot be true. Second one being true, that just means f of y is equal to b. Okay, and the first one is also like, okay, that's saying f of x is equal to b because it's false, right? So that doesn't make any sense. The only condition is like third one must be true. That's what we did the last time as well. So the third one is true. So f of z is equal to a. So z goes to a. Okay. Then f of y is not equal to b. So there's only one way y can go to c because it's 1 function, right? Okay. Uh, and then the first one is false, so x must go to b, basically. Okay, just calm down. Is this correct or not? Just start checking this. So third one is correct and these two are false. So the false of this guy is like x is equal x goes to b, which is correct. Then the false of this guy is y does not go to b, which is also correct. And the false of, sorry, it's not a false of that, it's the correct of, oh, it does not go to a. That went wrong. So it does not go to a. Okay, calm down. X is equal to b, so x goes to b. At least that one is correct. Then y does not go to b, it can only go to c. Oh, but oh, right, that's how we got this going to a. Okay, I didn't check if it's right. There's no way that you can have a function like that. That's the main problem, right? Oh god, that's just wrong. We checked all of them sequentially and none of them actually turns out to be working. So 19th, right, no f like that, right? That's the thing. Oh god, that was not nice. Okay, that's done. What about 20? So 20, they are saying D is correct. None of, oh god, seriously. They should have really wrote down an option that no such f exists, but fine, none of these. Maybe that makes sense. Right. So unexpectedly, they were in fact correct this time. I really thought they just copied down the question incorrectly, but no. Okay, that makes sense. And where else did I go wrong? Just in these three, of course. So yeah, that's it. Let's go to the next exercise now. Next exercise, Inchapter exercise 3. Come on, where is it? Ah, right, here it is. How many questions? Once again, 15, whatever. Yeah, just start. First question. G of x is equal to 2x plus 1 and f of g is equal to this thing, then range of f is. Okay, so f of g is this, right? And g of x is, hey, isn't it like, okay, I get it. It's just 4x plus, yeah, basically it's like 2x plus 1 squared plus 6. So let me guess, f of x is just equal to x squared plus 6. Easy as that, right? Yeah, because f of, g of x is basically just equal to g of x squared plus 6, right? And that's, okay, that way it's easy to see what f is actually doing. So what's the range of f? It's 6 inclusive to infinity, which is D. Second question. F of x is this piecewise definition. Okay. 1 minus x if draw out the graph. So first you got 0 to 1. Both inclusive, it's just 1 minus x. At x equal to 0, it's just going to be 1. Right? And then it goes to 0, basically. Both inclusive, right? You got 1 over here. Next you got x plus 2. So between 1 and 2 you are saying, right? So at x equal to 1, approaching 1, it's just 3. just goes to 3 basically, and it comes down. No, it actually goes up. God, I need more space for this guy. So 3 is somewhere over here. Okay, it's 3, and then it goes up once again. So till 2, that is at 2, it's going to be one more because slope is 1. So 4 makes sense. Okay, and then what? 4 minus x in this range. So 2 inclusive, right? It should be not inclusive. So whenever 2 is included, right? Okay, you got 4 minus 2 is just 2. So we go to this point, I guess it's included. And at 4, it's going to be 0. So 4 is over here, I guess. So now go to 0. Cool. So now what do they want us to do? Then f of x. Oh god. For 3 less than or equal to x is less than or equal to. So first of all, what is f of x for this range? So 3 less than or equal to x is less than or equal to 4. So it's like in this particular range, right? It's just this guy. So this guy, right? It goes from 0 to 1 over here. The slope is 1, of course. Right. So at 1, what's the thing? Right. Okay, just look at this, guys. Root of 1 is what this will be. So this is mapped to this, and that's mapped to that, and then it's linearly increasing. So this is the graph, basically. Right. So, of course. Hey, you have to actually... Oh, God, really? That is not good. So 3 to 4, it's this thing. It's 4 minus x. But that... Right, this value actually falls into the first category, right? So 1 minus this guy, right? So 1 minus 4 plus x, which is x minus 3. So B is the answer. Next question. Okay, we didn't actually have to graph this out, but whatever. Third is f of x is equal to this. So 1 minus x if x is less than or equal to 0. Right. Range of g of f of x. Okay, this time we have to graph this out. Right. Let's do it. So first for f, it's 1 minus x if x is less than or equal to 0. So you got 0 as the only important point. It's 1 minus x. Okay. If it's less than or equal to 0. So x equal to 0 is just going to be 1. Then it's like this basically. Okay, and so it's 1 minus x like that. Whatever. And what else? If x square, if x is bigger than 0, so at x equal to 0, it's 0, and then it's like that. Okay, so f of x. Wait, yeah, okay, you want g of f, right? So first f has the range going from 0 to infinity basically, right? Because all of these are like included. You get the idea. You get the idea. Okay, so just you just figure out the range of g of f. So yeah, basically the range of g in the positive values. So right, negative. Just graph this out first of all. You got 0 and then 1. It's negative f, negative x if x is less than 1. Yeah, right. So it's like this guy. Inclusive, not inclusive. Okay. And then it's 1 minus x if x is bigger than or equal to 1. So at x equal to 1, it's going to be 0. That's inclusive. Just keeps on going like that. Cool. Yeah, that makes sense. So, like 0 to negative infinity. Negative to 0. That's the range of g. 0 inclusive, by the way. Cause, wait, no. You will never have 0 in the first. Yeah, like f cannot ever be 0. That's right. F cannot be 0, unfortunately. Oh, but it can be 0 over here. So whenever x is equal to 1, and it can be 1, as you can see over here, it's 1. So whenever it's 1, yeah, at that point, it's just going to be 0. So actually, it is inclusive, right? So negative infinity to 0, inclusive. That's the range. Which is which option? A option. Next question. Fourth is if f of x is equal to this guy, negative 1 plus mod of x minus 2. Okay. Then f of g is, okay, in appropriate domain is, So, okay, you already got 0 is less than or equal to x is less than or equal to 4. At that point, you got f. And you want f of g first of all, right? So for g to be in the domain of f, you just want 2 minus mod x to be, less than or equal to 4 and less than or equal to 0. So basically, like minus 2. Minus 2 is equal to negative 1. So mod is equal to 2. So mod x is equal to maybe other equal to negative 2. And this is obvious. So the only thing is like mod x is equal to 2, which means x belongs to this guy negative 2 to 2, right? Okay, that's the thing from this condition. And then you also got this to be in the, okay, in this range. So negative 1 to 1, sorry, negative 1 to 3. Yeah, like negative 1 is inclusive and then 2 is inclusive. 2 to 3, nope. Okay, right, that is the, wait, you just want f of g, you don't want, oh god. Right, you got the appropriate domain and now just have to look for, what exactly is it in that range, right? So g is, what is g of x in this range? Mod of, oh god, it's kind of crazy, isn't it? Huh. Right, that is crazy actually. Wait a second. X plus 2 USA. Ah, god. Yeah, well, whatever. Just graph this out. Maybe graphing this out is better. Okay. Those are just linear functions, first of all. So let's try to do it. Just negative 1, and then you got 2 over here. Probably also should do this thing. Okay, so first of all, right, what is g of x like? So it's 2 minus mod x, right? Mod x is like this, negative mod x is like this, 2 minus mod x is like, yeah, I get that. It's like this. Cool. So at this point, it's going to be 2. At this point, it's going to be 1, whatever. And then you want f of x. So it's negative 1 plus mod of x minus 2. So these y values are now our new input, basically. Right? Okay. So x minus 2, you are saying, look, the thing is the maximum value of this thing is already x minus 2, right? Because you got 2 minus mod x. So yeah, basically negative mod x, the mod of that guy, which is just mod of x once again. So it's really just negative 1 plus mod of x. That's what this f is really. Cool. That makes sense. So x minus 2 is just this thing. Okay, you take the mod of that. That's going to be just this guy. Right, so x equal to 0. What I'm doing is just x minus, so mod of g of x minus 2. I'm doing that first of all. So at negative 1, it's going to be 1 and whatever. At 2, it's just 2. You get the idea. And then you want negative 1 plus this guy. So, push it down like this. Negative 1, this is 0. This thing is 1. It's cutting it over here. And then you got, just go up. Whatever. Naturally doing it. So at 2, it's just 1 over here. Makes sense? What do you want? Right, you just want the function. So that's pretty easy. Just negative 1 plus mod of x. Yeah. Cool. That's what we got. So C is the answer. Next question. Fifth, sometimes you don't have to graph this. I should not have graphed this. Okay, whatever. Next. But I just had that insatiable, urge to graph this out. Fifth, f real to real be a function defined by this thing for some positive a. If f of square root 2 is equal to negative square root 2, then the value of a is, okay, f of x is equal to this guy. You are saying f of square root 2. So what's f of square root 2? It's just going to be f of square root 2 is just 2a minus square root 2. And then you're saying f of that guy, right? So this guy, a times of this guy squared, 2a minus square root 2, that guy squared, and then minus square root 2, right? And that is equal to negative square root 2. So this thing is equal to 0 basically. What does that mean? Either a equal to 0, okay, then the value of a, oh, positive a, okay, then this cannot happen. Or 2a minus square root 2 is equal to 0, which just means like, okay, a is equal to square root 2 upon 2, which is 1 upon square root 2. There we go. So D should be correct. Next question. Yeah, I should think. Okay. Sixth. Let P and Q be polynomials such that P of X and Q of X have the same number of roots. What? Oh God. Roots in terms like okay, real roots, I guess. Is that correct or not? Real roots, right? Not complex roots. Okay. If the degree of P is 7, then the degree of Q is. Oh God, this is some weird thing going on. Same number of roots. Degree of P is 7. Degree of Q is. Clearly, Q must have at least one root. Wait, okay. P of Q of X. Right. This could either go to be like all real numbers if somehow P is. Wait, degree of P is really 7, huh? So, like P goes from negative infinity to infinity if the thing inside that is also going to infinity to negative infinity. So, okay, if Q's degree is odd, then that means like, okay, this can go to all real numbers. So Q of all real, okay, that must, right. Yeah, sure. Same number of root basically. This must also have 7 roots, 7 real roots that is. So, it can have any degree that is more than 7 and at the same time odd. That's kind of complicated, right? Oh God. Suppose you do. What happens if Q is like having an even degree? Then Q of X only goes from 0 to infinity. Okay, not even 0. Some number to infinity, right? It's bounded. So P is also bounded because it's cubic and whatever. So it's also going from some number to infinity. But then Q of some number to infinity is also just some number to infinity. Hopefully that number is. Wait. Oh God. There's no way we are going to be able to do this thing. Degree of Q is 0? Maybe. No, that can't be the thing. Q can't be a constant. That would not make sense. Same number of roots. Ah, the whole problem is like, okay, God, I don't know how to do this thing. Q could have degree being 7. I don't know. Like this guy. Wait a second. Wait a second. Say Q has, I don't know, n roots. Okay, it's got n roots. Then P of Q of X is equal to so say one of these roots, right? Yeah, sure. Oh, this is very weird. How do I even do this thing? Two polynomials, same number of roots, not the same roots, but the same number of roots. And the degree of P is 7. Okay, the degree of Q is. You should have at least 7 roots, right? At least 7 real roots. Q should have. So, wait, no. The roots of this guy is very different than that. Okay. This is kind of complicated. Can degree of Q be 0? No, it cannot. Can it be 1? If it's 1, it's like some kind of, okay, yeah, it's just a linear function. Sure. So there's only one root for Q of P of, like, okay, Q of X equal to 0, but just means like P of Q of X can only be a single value. Uh, yeah, that's kind of complicated. Okay, right. Mm-hmm. This was 0, that would make more sense, but it can't. Q of X is just kind of linear function. I get it. How am I supposed to do this? If we can't allow complex roots, there's no way I'm going to be able to do this thing. Because you can just add something that has, no real roots and, right, it's going to make the degree higher. There's no way I'll be able to do this thing. How do you even do this thing? whatever. Say Q has degree n. So you got 7n and then once again n, so like 7n squared. That's the leading coefficient's power. Sorry, the leading term's power, right? The degree of this guy, Q of P of Q of X. Now this has like 7 roots. So this must be bigger than or equal to 7 at least, which means n squared must be bigger than or equal to 1. Yeah, that's all you could get. It's either 1 or bigger than 1. There's no way you're going to be doing anything with it. Okay, 6 is weird. I don't know. Is there a way that we can actually figure out the degree? I mean, it should be that degree. We can somehow prove that the degree of Q must be some certain number. I don't think we can. Well, if this was like complex roots, it would have been a piece of cake, but no, it's not like that. So, next, 7th. Fundamental period of the function f is equal to sine x plus mod of sine x. Yeah, whatever. Okay, sine x plus mod. Hey, so, right, try to graph this out or something. Sine x is a function like this, or whatever, right? So it has period 2 pi. Yeah, whatever. You get the thing. I mean, clearly 2 pi is a period, so it's, yeah, okay. 2 pi upon some integer, that's the period, right? What would that integer be? It could be 2, it could be 3, whatever, right? Okay, mod of sine x. Right, so first of all, for, whenever sine x is like negative, right, this thing just makes it to be 0. So that's gone, cool. And whenever it's positive, it just, buffs it up to 2 times what it should be. So something like that, right? And then this thing, as you can see, it's periodic in 2 pi only. There's no other way that this can, yeah, right. That's how it should be, right? Of course. Okay, just, stack up one of these guys. So you got this, then that, that. You get the idea. This thing is 0, this thing is pi, this thing is 2 pi, this thing is 3 pi. You got some thing over here, okay, like this. Yeah, the derivative must also be the same if it, you get the idea. And that's basically saying that 2 pi is the period. There's no other way. Of course. You might think, okay, maybe pi is the period because, okay, this is not pi. Yeah, that pretty much disproves the fact that pi can be the period. It isn't the period. Yeah, 2 pi is the period. So A is the answer. Next question. 8th. Fundamental period of the function f is equal to square root 3 cosine x minus sine of x upon 3. Right. Hey, didn't I actually write down something about, these kind of functions, right? I did write a whole proof of why if you got something like a sine of ax plus b, sorry, ax plus alpha and then plus b sine of bx plus beta. If you got a function like that, which I mean, yeah, it can be written like that in the end, then the only way for this to be periodic is, and the period also, you can figure that out. The only way is that a must be some integral multiple of some base number, and then b must also be an integral multiple of the same base number, right? Only in that we can have the period. So the period of this guy is like 2 pi upon a, for this guy is like 2 pi upon b, right? Of course, and then this is like basically 2 pi upon mt, and that's 2 pi upon nt, right? Those are the fundamental periods basically. So now n times of this guy and m times of that guy, that's like 2 pi upon t. That would be the period, the fundamental period basically. So that's the LCM of these two periods, right? That can be the only period, and it is periodic if and only if this actually works out, right? So A and B can have an LCM, only then will we actually get this thing. In this particular case, what you have is got 1 and 1/3 as A and B values. So what's the LCM of A and 1 upon A and 1 upon B? So the period really is just 2 pi, and then you got 6 pi. What's the LCM? 6 pi, of course. Makes sense. 6 pi is the period. B is the answer. Just go and read that thing that I made. That is a proof of why this works. Okay, ninth. Right. Fundamental period of the function. Once again, same kind of stuff. Just figure out the period, take the LCM. That should be doing it. Yeah, okay. So sine of 2x upon 5. Whatever. What's the period for this guy? 5 upon 2 times 2 pi. Right? So 2 pi times 5 upon 2. And this guy is like okay, 2 pi times 7 upon 3. You just want to figure out LCM of these guys, right? Probably just multiply by 6 or something to make this integers, or maybe you can do that. LCM of these guys. Ooh, that's a weird question. LCM of 5 upon 2 and 7 upon. You have to sort of make the denominators common. So you got 15 upon 6 and 14 upon 6. LCM of these two guys basically. The only way I see is like 15 times 14 upon 6. That's the only LCM that could possibly be. So really just 5 over here, you got, 2 over here, you got 7. So 35 is the only LCM. Maybe it is, who knows. Yeah, got to be a thing. Sure, it has to be like that. So 35 is the LCM, so like 70 pi, that's the thing. C. Is 35 pi some equal of 35 pi? Uh-oh. Oh, yeah, okay. 35 pi is equal to 2. You know what? 5. Some multiple times 5 pi. Of course, that multiple must be 7, right? And then 35 pi is equal to some multiple times. 7. Okay, 14 times pi upon 3 or something like that. So this is 5 over there. That's going to be 2 over there. So m is just equal, that pi cancels. M is just equal to 15 upon 2, which makes no sense. It's not an integer. So what do you get? 70 pi is the thing. Next question. 10. Fundamental period of the function sine squared of x plus cosine power 4 of x. What is this? Okay, the fundamental period of this guy. Just do 1 upon 2 and 2, you get the thing. So 2f is basically equal to 1 minus cosine of 2x plus 2 cosines. Oh god, we should probably do 4 cos that will be better. So 4f, that is equal to 2 minus 2 cosine of 2x plus 1 plus cosine of 2x to the power of 2 basically. So that's just equal to 2 minus 2. I'm going to write this as c only, not writing that 2x or whatever. Then you got 1 plus 2c plus c squared. So that's going to be just 3. Oh, that cancels. That's perfect. 3 plus c squared. So basically 8f is just equal to 6 plus 1 plus cosine of 4x, which is like, okay, 7 plus cosine of 4x. What do you get? So f is just equal to 7 upon 8 plus 1/8 of cosine of 4x. Yeah, which means the period is 2 pi upon 4. That's pi upon 2. So D is the answer. Next question, 11th. I'm going very slow, am I not? Yeah. Fundamental period of the function f of x is equal to, once again, the same kind of stuff. 2x upon 3, then you got sine of 4x upon 5. Just hate all of this. Figure out the LCM of 2, okay, 3 upon 2, and then, 5 upon 4 or whatever. I'm guessing 4 times something. Yeah, you get the thing. Multiplies by 4, it's going to be just 6 and 5. Yeah, basically. 30 is the LCM, right? So, 30 upon 3 upon 2, that's going to be just 20. And yeah, okay. These must be co-prime. You get the thing. M and N values, that's what I'm trying to figure out. Those must be co-prime, and then you're good to go. And what else? Just about 5 upon 4 is supposed to be 24. So these are not co-prime. Uh-oh. Something went wrong, isn't it? Well, that was clearly the thing. 6, 5, especially 3. So then why did it not work out? 30 upon this guy is like 15 and then, sorry, 6 and then that goes into 24 and this upon 3 upon 2. Something's not right about this guy. Oh, there's no need to multiply by 4. You just have to multiply by 2, sorry. So yeah, this is not gonna work. Multiply by 2, you get 3 upon 1 and then 3. No, multiply this thing by 2. So right, I almost forgot how to figure out LCM or whatever. Yeah, okay, that's the way it should be. The LCM of these guys, which is 15 upon 2. So 15 upon 2 is the LCM. That thing upon 3 upon 2, that's going to be just 5. So M value is 5. 5 upon 4, that's going to be 3. And then what? 6. Yeah. So M and values are these guys, which are co-prime, which means yes, this is the LCM in fact. 15 upon 2, that should make sense. 15 upon 2 is the LCM, and then this thing's time, yeah, this thing times 2 pi. Clearly. 15 pi is all in the period. Next question. 12th. Fundamental period of the function cosine of sine of x. Ooh, that's weird. Clearly pi is a period because yeah, sine of pi plus x is just a negative sine x, and then cosine of that guy just once again cosine of sine of x. So okay, pi is a period. What about pi upon 2, is that a period or not? So that's like cosine of x, which, right, that's not gonna work. What about, let's just say x equal to 0. So x equal to 0, cosine of 0 is 1. Right, that applies, it's just 1. Basically f of 0. F of 0 is 1. Okay. F of pi upon 2, what would that be? So cosine of 1, which is not equal to 1. So pi upon 2 is not a period, which means clearly f pi upon 4 is also not a period. So B is the only answer. Next. I'm wondering if I could have done this using copies. Okay, no. Don't do that. That's just too much. Okay, 13th. Period of the function f is equal to, okay, this stuff. Oh god. Denoting the function is. I don't like this. Period of this guy. Okay, I can't even, like, oh god. What do I do? Maybe think of like x minus, so, x minus fractional part of x or something like that. It's not gonna work. It's not going to work, is it? You can definitely write like fractional part of 2 times the fractional part of x or something like that. Yeah, but in the end, it's just inside a fractional part, that is too much. Okay, the period of this guy. Clearly, x is equal to 1 is a period, right? Yeah, sure, because if you think about it, it is just this guy, fractional part of x, and then plus fraction part of 2x, and so on, right? Till fraction part of nx. I mean, we can't write it as, some kind of normal stuff, but yeah. Think, is there really no way to do this thing? Like, this is periodic in 1 upon n. That's, oh god. That's just weird, isn't it? Okay, 1 is clearly a period. Is n a period? Oh, it's not. Oh, it is periodic. How can you say it's non-periodic? Okay. N, yeah, that is a period, but that's just bigger than 1, so disqualified. 1 upon n. That's a period for this guy. Is it going to work for all of these? I don't know. Let's try out something. Let's try x is equal to 1. So, no, okay, x equal to 0. X equal to 0, this whole function just becomes 0. X is equal to 1 upon n. This becomes 1 upon n plus, I'm thinking of some stuff. So 1 is a period. What about 1 upon m? Right? That would be a period as well. Sorry. If that is the fundamental period, yeah, we know 1 is a period, then it just must be m times the fundamental period. So 1 upon m could be the fundamental period, right? So x equal to 0 is just 0. X equal to 1 upon m, right? It's fraction part of 1 upon m and then all that stuff, right? It's 0, 0, 0, 0, 0 until, you get something on the top that's bigger than m. And then you're going to get 1 and so on. So that will be more than 0. So the condition is that, yeah, right. M must be bigger than n for this to even happen in the first place, right? Because if it's not, then yeah, that's kind of complicated. So if m is equal to n, it's got 1 or something. Wait. Is that correct or not? Uh, no, that's just the fractional part of 1. Okay, if it's equal to n, even then it works out because fractional part of 1. Yeah, okay, that's actually gonna work out. Cool. Somehow it does work out, but I'm not sure why. Okay. So it's clear it should be equal to n. Okay. Oh god, think about it. What can I do to prove that 1 is the period? Uh, okay, this worked out. I'll just go with, I don't know, 2 upon n or something like that. Yeah, right. There are going to be more of these guys. Right. So 2 upon n, huh? It's like more variableness or something. So yeah, okay, 2 upon m, I should say. So till m upon 2, everything is 0. At that point, it's 1. And then you start off at a streak of 1 and so on. Wait, no, it can't be 1. It's a fractional part. Okay, it's 0 once again. But then it's... okay, there's no way I'm going to be able to do this thing in time. That's a nice question. I'm guessing A is the answer. I don't know if it is the answer or not. Yeah. Think, is there no other way? What if I, okay, let's just say X is, a very small quantity, all right? Then this whole thing is pretty much just X plus 2X plus, yeah, till NX, right? So I'm gonna take this at 2, right? Take the F at 2 different values. So I'm just gonna say X is equal to H. H is a very small quantity, and X is equal to H plus 1 upon M, right? Cool. We'll see what happens. X equal to H is just going to be like, H plus 2H plus NH basically, which is n times of n plus 1 upon 2 times H. And at X is equal to H plus 1 upon M, what do you get? So first you just got like, okay, H plus 1 upon M. Then you got, so remember H is a very small quantity, right? So only till M minus 1 upon M are you actually going to get things that are, right, okay, the same thing as that basically. Then 2 times of that guy, cool. Like 2H plus, remember that is a very small quantity. This thing is negligible, right? Okay, and then you got 2 upon M and so on. Eventually, you're going to get M minus 1 or something. So M minus 1 times H plus M minus 1 upon M. Now we're getting pretty close to 1, but this is still not that close to 1. And this is a very small quantity. I don't have it in mind that all the time. So it's still not, yeah, it's still not there. But then you have M somehow, right? So we know that M actually has to be equal to N. Only then it's going to work. Wait, but that means you will never have M unless, of course, M is equal to N. So it just keeps on going, huh? Okay, you're finally gonna have N upon M and then N minus 1 H plus this. Right, so if M is equal to N, then this thing is just equal to this guy and not, yeah, okay, that makes sense. Right, but this is still there, so no big deal about that. Got H plus 2H and so on, right? So cool. Wait, did I really just say M is bigger than or equal to, but then 1 upon 1, M is not bigger than or equal to N? How does that even make sense? No, something's not right about this guy. Oh god. Oh god. Right, the thing is, like, okay, this is kind of complicated. What if I'm just made H to be irrational? Then you would always have, right, okay, this thing, like, okay, the fractional part of, some integer upon M plus the same integer times H, right? This has to be bigger than or equal to the fractional part of K times H, which is equal to K times H, right? This has to be bigger than or equal to that. Yeah, that's right, of course. because yeah, like this is an irrational number. So the thing is, like, this is just equal to k upon m plus kh minus some kind of integer, basically, right? So this has to be in the end irrational. Okay, this is not right. You can't just say that. That's just not correct. God, this is so weird. Is this inequality correct or not? Is it just some kind of rational number or whatever? Plus k times h. H is just some infinitesimal quantity. It must be. It must be right. It has to be equal to k times h. I mean, if you think about it, like, yeah, this guy, it can go from 0 all the way till so when it's m minus 1, just got like m minus 1 upon m. Just k times h. Instead of like, say capital H. So capital H is another infinitesimal quantity. If k is finite, you can do that, of course. It's the other equal to h, basically. That's what I'm saying. So yeah, this is actually true, because the thing is, this can go from 0, and then like 1 upon m, 1 upon all that stuff, right? So 1 upon m plus h, 1 upon m plus h. That's what the fraction part returns. That's bigger than h. 2 upon m plus h bigger than h. So on. M minus 1 upon m plus h, that's m minus 1 upon m plus h, which is bigger than h. M upon m plus h, that's just h, which, yeah, I mean, it's equal to h. So this inequality always holds. That's the thing. But yeah, of course, that's the thing. Like this whole stuff that we have been doing, right? Fractional part of, yeah, all that stuff, right? Just put h plus 1 upon m over here, and then this whole thing, we know it's actually bigger than or equal to this guy, right? So yeah, and it's clear that when you put 1 upon m whenever m is not 1, right? So whenever m is not 1, this thing is a fraction, which means h plus 1 upon m, that's actually more than h, right? So the equality doesn't actually work out. It's an inequality, right? So this whole thing is actually bigger than n times n plus 1 upon 2 times h. That makes sense, right? Which means the only way for this to be periodic is that m must be 1. Yes, I proved this. Cool. That feels nice. Okay, so that's done, which means this must be 1. That was actually a nice question. I guess we should make a note of this thing. No, whatever. 14th. I never thought I would have to use infinitesimal quantities for this, but yeah, that's what it is. Okay, 14th. Consider those functions f that satisfy x plus 4 plus f. Sorry, f of x plus 4 plus f of x minus 4 is equal to f of x for all real x. Any such function is periodic, and there is there's a least common positive period p for all of them. The value of p is, oh, that's weird. So x plus 5, f of x plus 4, f of x minus 4 is equal to f of x. Interesting. That's like saying f of x plus 4 is equal to f of x minus f of x minus 4. So, okay. What about f of x plus 8? It's going to be f of x, yeah, basically just replace x by x plus 4. But then f of x plus 4, you know what that is. It's just f of x minus f of x minus 4. And then you got minus f of x, right? You know the thing, what I'm doing. This is actually equal to this guy. But then that's equal to this guy, and that's equal to negative f of x. So this cancels. It was not here, by the way. This is the thing. So like f of x plus 8 is just equal to negative of f of x minus 4. Now just put x plus 4 instead. So like f of x plus 12 is equal to negative f of x. So f of x plus 24, that's equal to f of x. Cool. So 24 is a period. Okay. So 24 upon that would work as well. So what about 24 upon 3? Does that work? So what you're saying is that f of x plus 8 is equal to f of x. I don't think that works like that, buddy. Yeah, doesn't look too good. You'll have to prove that this thing is actually equal to f of x. How do we even do that? That doesn't make any sense. It's equal to f of x. And how? How is the question? If this was having like fx times 2, that would have made perfect sense. Like 2fx. Then you just, yeah, make this. Okay, that would have been easy, but now it's not. Least common positive period P for all of them. 2024 might be a choice, but you have to make sure that it is the period. Okay, 16 is just not correct because 24 upon m can never give us 16. It can give us 12, but you already got this condition, so that disqualifies that. Then the only condition is, okay, maybe 8 is going to work. But then we have this thing, and okay, this is very weird, isn't it? What about, okay, f being the zero function? That would make sense, right? I mean, like, it's going to satisfy this thing, but then it's not periodic because the zero function is not, yeah, it like has period 0. uh, yeah, okay. Then the period is not 24 because it's 0. Wow, that turned out to be a contradiction very fast. Okay, they should have given us all non-zero functions, but okay, that's weird. Uh, now what do we do? Plus 4 plus 6 plus 4. I don't get it. Now what do we do? Uh, I guess 24 is the thing, because how can this be equal to that? That doesn't make any sense. It's equal to f of x plus 4 minus f of x is another thing. Cool. Okay, I'm just stuck at this point. How do I even proceed? Is 8 really a thing? So like f of x plus 8, is that actually equal to f of x? F of x plus 8 is f of x plus 4, which, right, I mean, you can be like that and all that stuff. I don't think that's correct. I don't think f of x plus 8 should be, you know, equal to f of x. Like Fibonacci numbers, huh? It's almost like Fibonacci numbers. And yeah, okay, what if, right, okay. Why is this, wait, no, how can this be negative? Something doesn't look correct about this. Ah, God. Oh, it's negative because that's gonna go over here. It's like f of x minus of x minus 4. Right. Okay. Cool. Oh, God. Yeah, whatever. Just put 24. It's hard to figure out what thing should be actual. Just guess. Next 15th. 15 is if f real to real is an odd function such that f of x plus 1 plus f of x plus 2 is equal to f of x minus 1 plus f of x, and f of 2 is. Okay. So this is like, put x equal to 0. You just get f of 2 plus f of 1 is equal to f of negative 1 plus f of 0, basically, right? And that should be nice. Any just like symmetric stuff over here? Look, x and then you got x plus 2. This thing and plus 2. What if I put, x plus 1? So instead of that, I just put x. So maybe that's not a good thing to do. I really want to do this though. Just like that. X minus 2 in that. Okay, that won't work. That's just really weird. No need for doing that. Okay, the thing is f of 2 is just equal to, f of 0 minus 2 times of f of 1, right? Now, the question is, how do we get f of 1? Right. Start putting more values in there. I don't know. Put negative 1. What do you get? It's going to be f of 0 plus f of 1. Oh, God. F of 1 is equal to negative f of 2 and plus, so when you put negative 1, it's like f of negative 1. That's negative f of 1. So f of 2 is also just equal to, f of 1. No, wait. F of 0 minus 2. Hey, it's the same question. Oh, God, it's the same identity that we got previously. That just, yeah, that didn't help at all. Putting x is equal to 0, we tried that out. Negative 1, tried that out. 1, no way. We definitely don't want to be doing that. But, wait, okay, my mouse is still not working now. Wait a second. So now, how do we do this? Odd function, this happens, f of 2 is. You could just guess, right? Sure, you can just guess. Some kind of linear function, no, won't work. Uh, Linear functions won't work, definitely. Something else, huh? A cubic function or whatever. It can't be a monotone increasing function because then you are, yeah, okay, this won't work. These two are less than that, right? So it can't be an increasing function for sure. Okay, but then it has to be an odd function. So sine or something, sine of pi x, sine of 2 pi x, right? Sine of 2 pi x. So sine of 2 pi x plus 2 pi. Okay, that's gonna be sine of 2 pi x. That's like once again just 2 pi. Ah, of course, that's gonna work out. So maybe it's sine of 2 pi x. Who knows? Then f of 2 is sine of 4 pi, which is just 0. So you are saying it's gonna be equal to 0. Wait, how? How is that correct? You'll have 3 at some point, and then maybe you should just start putting. So you tried 0, you tried -1. What about 1? That was the question. It's a weird thing going on over here. What do we even make of this thing? Like, what do we do with this? It's a negative function. Whatever. Hey, what if we just get rid of one of these sides? Hey, that's actually a nice idea. Okay, what about this guy? Let's say x is equal to 1 upon 2. Then this whole thing will go to 0 and just got f of. Yeah, but how is that going to help us? I don't know. Just keep on going. It will probably help us. And then f of 1 upon 2 plus 2. That's just 5 upon 2. That's equal to 0. Okay, you can do the same thing over here as well. So just put x is equal to. Yeah, that's what. So you can get rid of these guys somehow, basically. Sure. So you can also put x is equal to 3 upon 2. Then this is going to be 0 is equal to f of 3 upon 2 minus 1. Oh god, very weird. Oh wait, no, not 3 upon 2. It should be negative 3 upon 2 because then it's going to be negative 1 upon 2 and 1 upon 2. That's going to cancel out. Negative 3 upon 2 minus 1. That's just negative 5 upon 2. And then plus f of negative 3 upon 2. That's equal to 0. Once again, the same situation as that. So how did this even help? It didn't. Yeah, that didn't help actually. Okay. It's progress, I guess, because like, okay, 5 upon 2 and 3 upon. Let's put x is equal to 3 upon 2. What would that do? So you got 3 upon 2 over here, and then 3 upon 2 minus 1. Let's try that out. So f of 5 upon 2 plus f of 3 upon 3 upon 2 plus 2 is like 7 upon 2 is equal to f of 1 upon 2 and then plus f of 3 upon 2. But remember, f of 5 upon 2 and f of 3 upon 2 added is 0. So, okay, that didn't work out at all. Ah, not nice. So I'll get that over there. Yeah, that isn't helping out. Okay. F of 3 upon 2 plus f of 5 upon 2 is equal to 0. Here's some kind of periodic function. So what if the period is 1, right? Well, sure, you can try that out. Hey, you know what? Yeah, let's try that out. F of x plus 2 is equal to f of x plus f of x minus 1 and negative f of x plus 1. So our guess is that period of x is 1, right? So what about f of x plus 3? That is f of x plus 2 plus, sorry, x plus 1 plus 2, I guess, right? So everywhere instead of x, just put f of x plus 1 and stuff. Yeah. Okay, that's not the best way. Who knows? Just keep on going. We'll get somewhere. And you got f of x plus 1, but negative. So negative x, negative 1 minus 2, just negative x. Wait, why is that negative? No, it should just be x minus 1. So you got f of x over there. And then minus f of x plus 2. But we know what x plus 2 is, right? So put that in there. Is this going to help us or not? Just f of x and then x plus 2, negative of that, by the way, right? So that's going to be just f of x plus 1 minus f of x minus f of x minus 1. What? That cancels. Okay, it's like 2 times of f of x plus 1 minus f of x minus 1. And now, replace. That's like f of x plus 3, isn't it? Okay, you know what? Replace x minus 1 by x. So this will be f of x plus 4, basically. Yeah, you should have done that already. X plus 4. Okay, that's equal to f of x plus 2. Hey, you can go ahead and do this once again. Cool. Minus f of x, right? But we know what f of x plus 2 is. It's 2 times of all that stuff. Okay, hopefully we'll get somewhere with this. So once again, that is equal to f of x minus 1 plus f of x minus f of x minus 1. And that stuff minus f of x. What's that going to be? Just f of x plus 2f of x minus 1 minus 2f of x minus 1. Wait, that's not plus 1, sorry. There we go. That should be the thing. Yeah, hopefully. So that's f of x plus 4. Or yeah, this is not helping. That's definitely not helping. It's not periodic or anything. We can't figure anything out from this. Well, 1 is definitely not a period because that didn't turn out to be that. I mean, yeah, just, guessing, you just get 0 as the answer because sine of 2 pi x turns out to be satisfying this equation. It's an odd function, it satisfies this equation, so it must be a0. But how can I even prove that it's going to be 0? Oh, come on. All of this center was something. It's 1, 2, negative 1, 0. Negative 1, 0, 1, 2. Everything is centered around 1 upon 2, You just make x plus 1 upon 2 replaced by x. So f of x plus 1 upon 2 plus f of, x plus 3 upon 2 is equal to f of, so plus 1 upon 2 is like f of x minus 3 upon 2 plus f of, right, this is kind of weird, isn't it? Okay, plus f of, yeah, x is replaced by x minus 1 upon 2 basically. Okay, that's interesting. Now what? You can of course put 0 over there. That will just mean f of 1 upon 2 plus f of 3 upon 2 equals 0. But we already know that f of 1 upon 2 is f of... Sorry, wait, what? Okay, that's weird. That is the thing, sure. But... moreover, it's an odd function, isn't it? Hmm. It's an odd function. Hey, wait a second. F of 1 upon 2 plus x, and this can be as negative f of 1 upon 2 minus x. So basically plus f of 1 upon 2 minus x, and then we got f of 3 upon 2 plus x plus f of 3 upon 2 minus x. That's equal to 0. Okay. If this was just this much, it would be something like a point symmetry and whatever, but no, it's not. Probably x plus 1 upon 2 once again. So, instead of doing all of this, you just said x plus 1 upon, so x plus 1 is equal to u, then, okay, that would not have worked, unfortunately. Right, but now that we have this thing, maybe we can actually get this done or somehow. No, it's not that easy. You can't do it right away. That won't help. It's at 1 upon 2 as well as 3 upon 2. It's symmetric. Oh, God. Now what do we do with it? This is a weird thing, isn't it? So, okay, that's equal to 0. Yeah, right. And this is for all values of x, isn't it? Mm-hmm. You just need to figure out what f of 2 is, and then you'll be done. Okay. How do I get f of 2? one of these guys, right? So 3 upon 2. It's going to be 0 over there. It's f of 0. Hey, you don't even know what f of 0 is. That's just not helping. Come on, think about it. How do you even get f of 2 from this guy? What about x equal to 1 upon 2? There's only f of 2 over here. That's 1 over here. Then you got, that's 0. Okay, and that's just 1. So f of 1 plus, okay, that's like saying f of, so 1 upon 2, that's going to be 2. F of 2 plus 2 times of f of 1 plus f of 0 is equal to 0. What about x is equal to, x is equal to 3 upon 2 or something like that, or maybe negative 1 upon 2. That's like saying f of, well, okay, negative 1 upon 2, just switch these out, not helping. What about f of, what x is equal to 3 upon 2, right? That's the question. Just put that, we'll see what happens. F of 2 from here, then f of 1 upon 2 minus 3 upon 2, that is just f of negative 1. Then 3 upon 2 plus 3 upon 2 is just 3, so f of 3. We don't want f of 3 actually. Then why is this coming over here? What is going on? And that's 3 upon 2, this is 0. So that's the thing. That's equal to 0. Yeah, that didn't help at all. That's like saying f of 3 is equal to 3 times of f of 1, isn't it? Interesting. Okay, that's one thing you got. F of 3 is equal to 3 times of f of 1. So the 3 upon 2 gave us this guy, didn't it? Okay. You can keep going like that probably. What if I just put x is equal to 1 in here? That would be like f of 2 plus f of 3 is equal to f of 0 plus f of 1. But you know that's just this guy. So, okay, you're going to get the same equation from that. Not helpful. I guess, yeah, just have to leave it like that. There's no way I'm going to be able to do this thing, without some special conditions or whatever. Seriously, is there really no way of doing this? Or whatever. That's it. See you guys in the next video.